In question 1, I need to work out the speed given the distance and the time. Now I know that speed is equal to distance over time. Since I want the speed in kilometers per hour, I'll need to convert my time into hours. So 9 hours and 45 minutes is 9 hours and 45 out of 60, which as a decimal will be 9.75. So 7/800 over 9.75 will give me 800 kilometers per hour. In question 2, I have a triple ratio. Penny to Amjit to James is equal 3 to 6 to 4. Amjit gets 28 more than James. So this difference here, which is 2 parts, is equal to $28. So 1 part is equal to $14. So Penny has 3 parts, and 3 parts is equal to $42. In question 3, I'm given a frequency table with some distances and frequencies. I need to work out the model class. Now the model class is the class with the highest frequency. The highest number in the frequency column is the last one. So the model class is the class that has distances between 25 and 30. For part B, I will create 2 extra columns. One of them is labeled midpoint and the other one is labeled fx. F is the frequency. So what I need to do is find the midpoints of each of the distance categories. To do so, add the lower limit, the upper limit, and divide by 2. So I've got 2.5, 7.5, and so on. And then I will multiply the frequency with this number. So 12 times 2.5, and so on. Next step is to find the sum of the frequency column, which is 60. This is denoted as sigma f, the sum of the frequencies, and also the sum of the fx column labeled as sigma fx, and this is 1040. So the mean is given by the formula sigma fx over sigma f, and I will just substitute the numbers from above to get an estimate for the mean, 52 over 3 or 17 and a third. Now 17.3 is also acceptable. Now for part C, we need the probability that a randomly chosen worker travels more than 20 kilometers. Now from our table, there are 2 categories above 20 with frequencies 14 and 18. So the answer to this question will be 14 plus 18 over 60. This is equal to 32 over 60. You can simplify if you want to 8 over 15. I'll start question 4 by first calculating the total cost. So cost equals 12 times 15 is equal to 180. Now, since I have a profit of 15%, this means that my multiplying factor is equal to 1.15. That's 115 over 100. So my sales will be the cost times my multiplying factor, which will give me 207. Now, these sales can be found by splitting the metals into 2. I have a total of 12 times 12, 144 melons. There are two selling prices. I sell 3/4 of those, that is 144 times 3/4, which is 108 melons at a price of 160, which will give me 172.80, and then the rest, a quarter, which is 144 times a quarter, which is 36 melons at an unknown price. So I'm going to write 36 times P, which is my unknown price. That's 36P. So when I add these two numbers, I should get my selling price. So I have an equation, 172.80 plus 36P is equal to 207. So 36P is 34.20. So P is 0.95, which is the reduced price. In question 5, I need a compass to draw the bisector of this angle. I'll start by putting the pin at point B and drawing an arc cutting lines A and B and BC. Then from these 2 points, I'll draw 2 separate arcs with the same length so that they intersect at a single point. And then I will join point B to this point of intersection. And this is the angle bisector of angle A and BC. For part A of this question, the common factor of these two terms is 9e squared f, and then I'm left with 2e plus 5f to the power of 3. For part B, I can solve this using either factorization or the quadratic formula or completing the square. I'll go with factorization. The two brackets are x minus 6, x plus 2. So the two solutions are x equals 6 or x equals minus 2. Question 7, I have a right angle triangle, I have the hypotenuse, and I need to find the adjacent. So cos of this angle 35 is equal to adjacent, which is PR over the hypotenuse 17.6. If I rearrange, PR is 17.6 times cos of 35. Use your calculator and the answer should come out to be 14.4 to 3 significant figures. In question 8, I'm given that the 15%, which is the discount, corresponds to 22.50. So the 100%, which is the normal price, corresponds to what? So to find the normal price, that's 22.50 times 100 over 15, and the answer comes out to be 150. In part A, 1.4 times 10 to the 5 is equal to 140,000. In part B, the smallest diameter belongs to Mars, that's the smallest number. In part C, I need to calculate the difference between these two diameters. So it's 1.2 times 10 to the 5 minus 5 times 10 to the 4. Now you're doing this manually, reduce to the same power. So that's 12 times 10 to the 4 minus 5 times 10 to the 4, which will give me 7 times 10 to the 4. Note the calculator can give you this directly. And then in part D, I'm given two new numbers. I want the ratio of the diameter of the moon to the diameter of the sun in this form. So 3.5 times 10 to the 3 to 1.4 times 10 to the 6 should be 1 to n. And if you divide by 3.5 times 10 to the 3, the answer will come out to be n equals 400. So the ratio is 1 to 400. In question 10, I'll start by finding BC, which is the diameter of the semicircle and also the height of the triangle. I will find this using Pythagoras theorem. So BC squared is equal to 9.5 squared minus 7.6 squared. So BC is the square root of this, which comes out to be 5.7. So the total area is the area of the triangle labeled 1 and the semicircle labeled 2. Now area 1 is equal to base times height over 2, so 7.6 times 5.7 over 2, which is 21.66. Area 2 is equal to pi r squared over 2, so pi times 5.7 over 2 squared over 2. This comes out to be 12.758 and so on. So the total area is 21.66 plus 12.758 dot dot dot, and the answer comes out to be 34.4, correct to three significant figures. And question 11, I'll start by expanding the last two brackets. Note that this is the difference of two squares. So x plus 5 is equal to x squared plus 3x minus 3x cancels out, minus 9. And then expand term by term, x cubed plus 5x squared minus 9x minus 45, which is the final answer. I'll start question 12 by first putting my numbers in ascending order. Now, to find the interquartile range, I will subtract Q3 minus Q1. Q3 is the upper quartile, Q1 is the lower quartile. Now, to find Q1, I'm going to divide n by 4, which comes out to be 2.75. So I will take the next integer position, the third one, in my case, 17. To find the upper quartile Q3, I'm going to find 3/4 of n. This comes out to be 8.25. So I'm going to take the next integer position. That's the 9th one. So this is the second 23. So interquartile range is equal to Q3 minus Q1. So that's 23 minus 17, which comes out to be 6 points. In part B, we need to state which of Carmelo or Cope is the more consistent, and consistency has to do with the IQR. The lower the IQR, the more consistent a player is. So in our case, it's going to be Carmelo because it has a lower IQR. I will start part A by finding the gradient of the line. I will do so by using the formula y2 minus y1 over x2 minus x1. So using these numbers, I've got 2 minus 5 over 1 minus minus 3, which will give me minus 3 over 4. Next, I will use the formula y equals mx plus c with my gradient of minus 3 over 4 and any of the 2 points above. I will use the 1, 2. So 2 equals minus 3 over 4 times 1 plus c. And then c comes out to be 11 over 4. So the equation is y equals minus 3 over 4x plus 11 over 4. I need this in the form ax plus by equals c with a and b c integers. So I will multiply everything by 4. So 4y equals minus 3x plus 11. And then I'm just going to take minus 3x to the left. So 3x plus 4y equals 11 is the equation of the line in the required format. In part B, I need to show that two lines are perpendicular. Remember, if two lines are perpendicular, the product of their gradients must be equal to minus 1. Now, m1 is equal to 3. I can read this from the equation. For m2, first I will need to rearrange 6y is equal minus 2x plus 1. So y is minus 2x plus 1 over 6. And if I split this into 2, I get minus 2 over 6x plus 1 over 6, or y equals minus a third x plus 1 over 6. So m2 is minus a third. So going back to my highlighted formula, 3 times minus a third is equal to minus 1. So they are perpendicular. And question 14, there are many approaches. I will proceed with the assumption that frequency is equal to area of each bar, and the area of the first bar is equal to 26. So to work out the height, I'll just divide 26 by 20, which comes out to be 1.3. So now I can complete the scale on the vertical axis and also on the horizontal one. So now I can work out the area of each bar by multiplying the width times the height. So for the second one, I have 10 times 3.6, which is 36. The next one is 10 by 3.3, which is 33. And the last one is 30 by 1, which is 30. So to find the total frequency, I will just add these four numbers, which comes out to be 125. For question 15, part A, note that the width of the big rectangle is equal to 2x plus 1, and the length is equal to 3x plus 1 plus 1, so that's 3x plus 2. So 3x plus 2 times 2x plus 1 must be equal to 100. Expanding this will give me 6x squared plus 3x plus 4x plus 2 is equal to 100. And if I rearrange, I get 6x squared plus 7x minus 98 equals 0 as required. Now, if I try and solve this equation, I will get 3x plus 14 times 2x minus 7 is equal to 0. Note, instead of factorization, you can use either the quadratic formula or completing the square. These two factors will give me x is minus 14 over 3, which I will reject because x cannot be negative, or x is 7 over 2, which is 3.5. So to find the area of the lawn, which is 3x times 2x, I will just do 3x times 2x, which is 6x squared, which is 6 times 3.5 squared, which will give me 73.5 meters squared. In question 16, I'll start by first finding angle BAD, then I will find angle ABD, and then finally angle ADB, which is the required angle. So let's begin. BAD is equal to 180 minus 103, which is 77 degrees. The reason is that opposite angles in a cyclic quadrilateral add up to 180 degrees. Then angle ABD is equal to 39 degrees because of the alternate segment theorem. And finally, angle ADB is equal to 180 minus the sum of the other two angles, which is 64 degrees. And the reason is that angles in a triangle add up to 180 degrees. I'll start this question by writing upper and lower bounds for each of A, B, and C. So A is between 41.5 and 42.5. B is between 23.5 and 24.5. And C is between 13.5 and 14.5. Now, I want Y to be low, so I'm going to take a low numerator with the upper bound of the denominator. And then the denominator I have a subtraction. To get a big value for this subtraction, I'm going to get the upper value for the first number, B, minus the lower bound for the second number. So I'm going to use 41.5, 24.5, and 13.5. So I've got 2 times 41.5 over 24.5 minus 13.5, and the answer comes out to be 7.5 to two significant figures. Question 18, note that there's a subtraction and a division. Now division is given priority, so I'm going to place 2 brackets here, and I'm going to work with this first. So x minus 1 divided by, and then I'm going to factorize. I've got x minus 1, x plus 1 on the numerator. Denominator stays the same. Now I've got a division by a fraction, so I'm going to change this one to multiplication by the reverse, by the reciprocal. So that's 3x plus 2, x minus 1, x plus 1. Now I can simplify the x minus 1 with the x minus 1. So I'll be left with 3x plus 2 over x plus 1. So if I put this together, 3 minus this fraction, 3x plus 2 over x plus 1. Now 3 has a denominator of 1, so I'll need to multiply this by x plus 1. So 3x plus 1 minus 3x plus 2. Note two things. First of all, I've got a minus in front of a bracket, so I need the bracket there. Second, I have a denominator of x plus 1. I cannot get rid of the denominator. So if I expand my brackets, that's 3x plus 3 minus 3x minus 2. Be careful with the minus over x plus 1. The 3x and the minus 3x cancel out. So I'm left with 1 over x plus 1, which is my final answer. Note a is equal to 1 and b is equal to 1. I'll start this question by using the fact that the curved surface area is 130. Now the formula for the curved surface area of a cone is pi RL, so pi RL is 130. Now I know that the radius is 4.5, so pi times 4.5 times L is 130, so L is 130 over 4.5 pi. This comes out to be 9.1956 and so on. Now to find the angle AVB, which is this angle here, I will first work with half of this isosceles triangle. I'll take the right half, which is this one. This is a right angle triangle. It has a base of 4.5 and a hypotenuse of 9.1956 and so on. So let's extract this triangle. So sine of angle x is opposite over the hypotenuse. So x is the inverse sine of this ratio, of this fraction, which comes out to be 29.29 and so on. So the angle AVB is equal to 2 times x, which is 58.6 to 1 decimal place. In this question, we're given this graph with the coordinates of the maximum point. We need to write down the coordinates of the maximum under these transformations. So the first one is a translation by 3 units to the left, or a translation by the vector minus 3, 0. So the coordinates of the new point are 0, 5. In the second part, we have a stretch along the y-axis by a scale factor of 2. So we keep the x-coordinate the same and we multiply the y-coordinate by 2 and we get 3, 10. And in the third part, we have a stretch along the x-axis with a scale factor of 1 over 3. So we multiply the x-coordinates by 1 over 3 or divide them by 3 and keep the y-coordinates the same. So the new coordinates of the maximum are 1, 5. And then in part B, we are given the transformation y equals fx minus 4, and we need to describe this one. This is just a translation by 4 units down, or more officially a translation by the vector 0, minus 4. Now the strategy for this question is to find the derivative, dy dx, set it to 0, solve the equation to get the x value, and then substitute into the original y equation to find the y coordinate. So let's begin by first writing this one as 2 times x to the minus 1. So I get y equals 8x squared plus 2x to the minus 1. So dy dx equals 8 times 2, that's 16x, subtract 1 from the power, so it's x to the power of 1. Then minus, because you have minus 1 times 2, so it's minus 2x, subtract from the power, you get minus 2. And then to find the stationary point, I'll need to set this equal to 0. Now, to help me with my calculations, I'm gonna, again, bring the x to the minus 2 as x squared in the denominator. Then I'm gonna take this fraction to the left, so it becomes positive. I will cross multiply and then divide by 16. So I've got 1 over 8 equals x cubed. So x is equal to the cube root of 1 over 8, which will give me 1 over 2. And then I'll need to find the y coordinate as well. So y is equal to 8 times a half squared plus 2 over a half. And then if I put this on the calculator, y will come out to be 6. So my coordinates for the turning point are 1 over 2, 6. And this question, I'll need to find expressions in terms of lowercase a and lowercase b for vectors BC and AE. Now let's use this fact that DE to EB is equal to 1 over 2. Well, if this is one part and EB is two parts, then this is like saying that DE, vector DE, is equal to a third of vector DB, and this will be useful at some point. So first, let's work out the vector BC. This is equal to BA plus AD plus DC, which is equal to minus 12a, I'm going backwards, plus 3b plus 18a, which I can simplify as 6a plus 3b. And if I take out a common factor of 3, this will be 3 times 2a plus b. Now, let's do the same thing for AE, but before I do that, I will need DB. This is equal to DA plus AB, which is equal to minus 3B plus 12A, or simply 12A minus 3B if I put it in alphabetical order. Now, vector AE is equal to AD plus DE, and now I can use the fact that DE is a third of DB, so this is equal to AD plus a third of DB. And then let's substitute. I've got 3b plus a third of 12a minus 3b, which is equal to 3b plus 4a minus b. If I simplify, that's 4a plus 2b. If I take a common factor of 2, I get 2a plus b. So note that both BC and AE are multiples of the same vector, which means that BC is parallel to AE. So let's write this as a conclusion. Before I begin, let's remind ourselves of two equations that are being used in this chapter. The nth term is equal to a plus n minus 1d. A is the first term, d is the difference, and n is obviously how many terms I have. And then the sum of the first n terms is equal to n over 2 times 2a plus n minus 1 d. We'll use the first statement to write an equation. So a plus 4 minus 1 times d is equal to 17. If I simplify, I get a plus 3d is equal to 17. I can use the second statement to write the second equation. A plus 10 minus 1 d is equal to 35. So a plus 9d is equal to 35. So then I can use these two equations to solve them simultaneously. So a plus 9d is 35. A plus 3d is 17. And I can subtract the two equations. A's cancel out. So I've got 6d equals to 18. D comes out to be 3. I can use any of the two equations to find a. So a plus 3 times 3 is 17. A comes out to be 8. And then I can use the second formula to find the sum. So sum equals 50 over 2. 2 times 8 plus 50 minus 1 times d, which will give me 4075.